When people talk about AI progress, they usually focus on model size and capability. But the more important question is often simpler: what exactly is the system trying to optimize? Because no matter how advanced a model becomes, it can only pursue the goals it is given. Every AI system is built around an objective function. That objective might be accuracy, engagement, cost reduction, risk minimization, speed, or some combination of these. The model is trained to improve performance according to that definition. From the outside, it can look like intelligence, but inside, it is optimization. And optimization always depends on what counts as success. Choosing an objective is not a purely technical decision. It reflects institutional priorities. A recommendation system optimized for engagement will behave differently from one optimized for user well-being. A pricing algorithm tuned for short-term revenue may act differently than one tuned for long-term customer retention. The model does what it is asked to do. The deeper question is, who decides what it should be asked to do? In many organizations, those decisions are shaped by incentives. If performance is measured in quarterly growth, models are tuned toward metrics that support that goal. If risk exposure is the primary concern, objective functions will emphasize caution and compliance. AI systems often amplify existing priorities rather than inventing new ones. This means that understanding AI's impact requires looking beyond code and into governance. You can see this clearly in content platforms. Recommendation algorithms do not decide what is true or false. They optimize for signals such as engagement, watch time, or predicted interaction. These metrics are chosen because they are measurable and linked to business outcomes. Over time, optimizing for them shapes what content gets visibility. It influences what creators produce and what audiences see. The model is not setting the goal, it is enforcing it at scale. A similar pattern appears in financial systems. Credit scoring models assess risk based on historical data and predefined thresholds. Those thresholds reflect institutional definitions of acceptable risk. If a bank prioritizes growth, the model may be tuned to approve more applications. If it prioritizes stability, it may become more conservative. The algorithm executes strategy. It does not define it. This leads to a common misunderstanding. When people criticize AI outcomes, they often attribute the problem to the model itself. But in many cases, the behavior follows logically from the objective it was given. If a system optimized for engagement surfaces sensational content, it may be doing exactly what it was designed to do. Changing the behavior requires changing the goal. A common counterargument is that models can be aligned to broader human values. Researchers and policymakers are working on fairness constraints, safety layers, and multi-objective optimization. These efforts matter. However, even advanced alignment techniques require choices about which values to prioritize and how to trade them off. There is no single neutral objective that satisfies every stakeholder. Optimization inevitably involves compromise. Another argument is that institutional priorities evolve. Companies adjust strategies, regulators introduce new rules, public expectations shift. That is true. Objective functions are not fixed forever, but updating them can be slow and costly, especially once systems are embedded deeply into operations. When AI becomes infrastructure, changing its goals may require revisiting contracts, metrics, and organizational incentives. Capability may improve faster than governance. This dynamic highlights why model sophistication is only part of the story. A highly capable model optimized for the wrong objective can produce outcomes that are efficient but misaligned with broader social goals. Conversely, a moderately capable model aligned with carefully chosen objectives can produce more acceptable results. The leverage lies in the definition of success. It also explains why debates about AI often feel indirect. Discussions focus on transparency, bias, or technical limits, but underlying many of these concerns is a simpler issue: whose priorities are being encoded into the system? Who has the authority to define what is optimized? These questions move the conversation from engineering to governance. None of this implies that AI goals are set maliciously. Most objective functions are chosen under constraints: limited data, limited time, and competing demands. Teams select measurable targets because they are practical. They respond to incentives that already exist within institutions. The system reflects its environment. Understanding this shifts how we evaluate AI systems. Instead of asking only whether a model is powerful, it may be more useful to ask what it is optimized to maximize, who benefits from that choice, and what trade offs are being accepted. Performance metrics tell us how well a system pursues its goal. They do not tell us whether the goal itself is appropriate. That distinction matters. As AI becomes more capable and more embedded, the importance of objective setting will increase. The systems will become better at executing whatever they are asked to do. The critical question will remain upstream. Who sets the goals? Who revisits them? And how transparent are those decisions? Because in the end, AI does not decide what success means. It optimizes toward the definition it is given. And understanding that definition may matter more than any single improvement in model capability.